Okay. I wonder if the recording is working. Doesn't look like.
It says it's recording.
Yeah, now it's all good. All right, I think we can start. Hello, everybody. Welcome to the Istio Networking Working Group meeting. We have, like always, very interesting topics in the agenda. The first one, it's discussing a proposal to achieve like Istio failover for ETS. And I will probably pass it to Jan to discuss his proposal and debate a bit on that, because there have been some discussions already. And second, John has a very interesting proposal about, again, about TDS, and it's called Endpoint Slice. From what I read a bit about and discussed with John, it's actually matching the first proposal, so maybe we can merge these two and give adequate coverage. And also Mitch later will discuss about config distribution stuff. So since there are three topics, I propose like 20 minutes for each of them. Let's, or maybe less, like let's say 15 minutes for each of them. Let's try to be on time. And please add your names to the attendees. I still see that not everybody is there. And Jan, please feel free to present.
Do you mind if we switch, because I think it's important to have context about the endpoint slice before you discuss the second one, since there are some implications.
I don't mind. I think
okay,
Jan,
okay. Sorry.
Yeah, one second. I will present.
Yeah, the two are slightly related, so.
Yeah, but this one is simpler and provides context for the second. So
yeah, this one probably actually won't take too long. Yeah, so basically Kubernetes added this new API in the 1.16 release as an alpha called Endpoint Slice. And the long-term goal is this will replace the endpoint object. Basically what it is it's endpoint with a few more fields added, and it's designed to be extensible. So it's actually not even part of the core API group anymore, because it's designed for things such as Istio to utilize them in our own ways. So they added a couple things like topology, which has first-class support for locality, and we can also add arbitrary metadata we want there. They have different address types, so we could probably replace our current resolution where we have some host names that are resolved in DNS and then some IP addresses. There are some things like missing fields that we have right now, like the weight, the L7 protocol, and export to. But I think a lot of those we could replace just by annotations or labels.
And if I can provide some context, the reason Kubernetes added this API is because endpoints, what they were using before, couldn't scale to larger number of hosts. We have exactly the same problem where service entry doesn't scale to large number of hosts. If we get to 1,000, 2,000, 10,000 endpoints, editing for mesh expansion, for example, becomes almost impossible, and the size becomes too large to set in protos and so forth. So that's how Kubernetes is going to scale. Mm-hmm. And because the API was actually inspired from Istio API and from our requirement, instead of duplicating the API, we can just adopt the API and gradually switch to this API, which is more scalable and satisfies all our requirements.
Yeah, so the reason it scales is because before there's one endpoint to one service. Now you can have many endpoint slices to one service. And so if you change one endpoint, you just have to update the one endpoint slice object that has maybe 100 endpoints, rather than this huge endpoint object that has like 10,000 endpoints, which is horrible for scale.
But this is basically a step in the right direction for what we called incremental EDS, right? Like the ability to receive one endpoint delta at a time. In here, we will receive a slice, which is still better than
this is basically Kubernetes.
It's sharding, not incremental. It's sharding the endpoints in multiple slices. It's not going to be incremental in any way, but just. Anyway, that's scalability. So far there is no other alternative to this from any point of view, because if you go to 10,000, what we have doesn't work.
Yeah, so this doc was just kind of a higher level overview of how we can embrace this new API. The first step is just support in pilot. We need to do this because otherwise, once people start using Endpoint Slice, there's no more endpoints created, and so pilot will not work at all. So it's just, we have to do this. It's probably not that hard. And this is in Kubernetes 1.16, so hopefully we could get it in 1.4, but it is an alpha right now, so I don't think anyone's really using this. But by like Istio 1.5, for sure, we need support for this.
So how will this work with Envoy? So what does it change in our like EBS?
Nothing.
Yeah, absolutely nothing. It's just a different input from Kubernetes. We get an endpoint slice instead of an endpoint, but we still can generate the same config.
One thing that will change for our users is that if they use Kubernetes 1.16, first of all, it will work instead of being broken. And second, they will be able to use mesh expansion or other features using Endpoint Slice and no longer have to use service entry. So they'll use a first-class Kubernetes API. And as a side effect, automatically it will be integrated and will be visible to Kubernetes. So Prometheus will be able to scrap it and so forth.
Yeah, that was my next point, is that once we get support, we can also just completely replace service entry with this Endpoint Slice. It serves the same functionality, but it simplifies a lot of things. We don't have our own CRD that we have to maintain, teach users about, document, etc. Like Costin said, we get first-class Kubernetes support, especially things like Prometheus will work out of the box. And they're really like almost the same API, so it doesn't really make sense for us to duplicate them.
Immediately being defined as 1 year from now when when 1.16 will be the minimum supported version. Sure. But people who use 1.16 can already start using it. And people who use older versions will continue to use service entry, of course. So the deprecation for it will be 1 year kind of.
Yeah, one thing this also adds is a new ready field for each endpoint, which I believe was the only thing that motivated the synthetic service entry. We can likely replace the synthetic service entry with this as well. So we're actually get rid of two.
At some point, yes.
So I'm sure this can replace the synthetic service entry. I'm not sure how it can replace the external service entries. Because
it's not. For now, no. For now, we are just talking about the existing endpoints, the IPs. There is a discussion separate. Let's not mix it up.
Yeah.
So I give here some examples.
Is basically the updates from like let's say Gale to Pilot, right? And all the processing code in Pilot. And I wonder if there is a similar like effort in the EDS, so that we don't download the full list of endpoints.
Yeah, that will be the next conversation.
Yeah.
Okay,
yeah, so here I gave some examples of service entries and their equivalent in Endpoint Slice. It's kind of hard to see on one screen, but if you look at them, they're effectively the same thing. So here's one for DNS service entry. Here's what it would look like as an Endpoint Slice. It's basically the same thing.
This one is not yet completely ready. That requires some changing.
Yeah, so Kubernetes actually right now the address types only supports IP, but it's still an alpha, and I'm pretty sure we can get them to allow a host name, so we can do the DNS stuff as well. I've talked to some of the people on the Kubernetes side; they seem open to that.
But 1.4 will go with for
1.4 we'll just go with support, and then we can adopt this more in the future. So the next thing is, Kubernetes now has scale of endpoints, and we don't, because we still send the full set of endpoints to Envoy. If you don't think that's a big deal, you can look at some big numbers that I put on this table. Basically, if you're going from 1,000 endpoints to 10,000, you're going to send 332 billion endpoints. It's just basic n squared problems. So we should come up with a solution in the near term to do some sort of incremental or batched EDS. One potential solution for this is what Jan is going to present. If we could have some sort of aggregate cluster that has many subclusters. So we'd have like our HTTP bin cluster, and then that would be composed of a few different subclusters which have their own independent endpoint sets. So that way, if an endpoint gets updated, we don't have to send all 10,000 endpoints, we can just send one chunk. Another one is if this was just, we had a first class support for this in EDS. I think there's been some efforts around that, like the DeltaX protocol,
but it doesn't solve the problem, because that solves the problem of one incremental update if you send one extra endpoint. But the initial send, it steals the full list, and it's still probably larger than the gRPC buffer size, and it's not going to work. So it's a palliative, but it's not going to solve the problem.
Yeah. Yeah. So that's pretty much.
No, it is actually how you use the DeltaX DS. You can send a small set of the endpoints first and send additional incrementally. That's basically how you implement that in Pilot.
But the original set, I mean, initially when you connect and you send the first connect, you still need to send the entire set, no?
No, you can send a small slice of that and add more in the like subsequent incremental XDS. That basically doesn't make any difference between the aggregate cluster, right?
Well, that's an alternative. We don't have it supported right now, so if
we don't have the incremental XDS is not fully implemented, so but that basically you can implement a Pilot to send in that way.
Okay, let's discuss it when we discuss the second topic, because that's where we discuss options. And but this is one valid option. Having cluster slices is one implementation option to address the scalability issues that we have. And yes, maybe that's another option with incremental.
So Lizanne, when you're saying it's implemented but not fully implemented in Envoy,
it is being implemented by I think Yuchen is in the review process on that.
Yeah, kind of. There are two layers of Delta. One is kind of the view at Envoy side. So your watch only see the slice differences, but actually between Envoy and Pilot, you will see a huge message that contains many endpoints. And the next step is to allow that the transportation between Pilot and Envoy.
But that means it's not implemented. So we can still make a choice to go with the cluster slices, or we go with the incremental, I think, since it's not yet committed.
Yeah, not yet.
Okay. Hear from some other. Okay. There was a bit of echo, sorry. So I'd like to hear also from other people on the line, their thoughts related to this particular proposal.
Endpoint Slice support for the Kubernetes adapter, that's fine. I don't think there are any state to replace service entry. I mean, or deprecate service entry per se. I mean, maybe for VM expansion and so on, that's great. Because service entry represents an actual service. It's an object that's actually declaring this is a service with so-and-so parameters and properties, and endpoint slice represents a group of endpoints that belongs to one or more services. So overloading that API to represent the services as shown in the examples here feels pretty wrong, especially. I would like to say, okay, this is how you can add additional external entries. That's not the right way to go. But we can definitely, like, either if need be, and if there are actual use cases that people come and say, you have a service entry with 10,000 endpoints and you would need to have some sort of like batching effort, we can always create an additional, like, referential endpoint sets or whatnot it is. But I don't think we've come across the case where somebody has come in and said, I have 10,000 endpoints in one single service entry, and adding and removing it is creating an issue. So
I tend to agree with you, because service entry itself, it's a mergeable thing already. So it's able to merge endpoints. So in this case, it would merge the endpoint slices, right? But it doesn't necessarily mean that the endpoint slice supersedes or completely gets rid of the need for a service entry.
Yeah, but as such, this proposal we should definitely support the endpoint slice on Kubernetes, but I think even if we support it, I think it's pointless until we update Pilot to do the incremental EDS with Envoy, because that's where the pain point is in terms of just the differential sort of.
I don't think it's pointless, because it's you either have endpoints or endpoint slice. So if anyone has endpoint slice enabled on their cluster,
sorry, I guess we will. We will not reap the benefits of this thing until.
Not fully. Yes.
Very true.
Yeah, not fully, but I think we will reduce some of the Pilot CPU and processing, and plus we will do it incremental in terms of effort and people who are working on it, because it's a different set of people working in Pilot and Galley versus the one working on the EDS, right? So that would need to change also in Galley, for Galley to create the those synthetic service endpoints with slices instead of actual services and endpoints in Kubernetes. Let's not forget we're trying to keep a certain abstraction in pilot, an abstraction from Kubernetes as well, right? So the changes would likely go more into Galley than in pilot.
Well, right now we are not using the endpoints from Galley, so it is not something that we have in any production system.
Well, we are not using, and one of the main reasons we are not using was exactly this one, was because we would get the entire list of endpoints, and I think that was causing us sort of an O(n) log n.
But I don't think it's the scope to switch to MCP to endpoints in 1.4. I mean, right now for 1.4 we need to move to endpoint slice so we don't break support for 1.6.
I don't see the benefit then.
Because
otherwise it doesn't work.
Yeah, if they have endpoint slice enabled on their cluster, it's completely broken. They can't use Istio. So we'll give them the option. You either need to change your entire cluster, or you can use Istio. And that's not really an option we want to make people decide on, right?
Yeah.
Right.
1.16 maybe because it's alpha, but once people start using this, then we have to support it.
This is just an internal stuff that we have to anyway add in Kubernetes adapter or wherever it is, because yet another way of reading endpoints from Kubernetes. That's it. I mean, if they duplicate one and add one, that's just part of the process. Us maintaining the interfaces with Kubernetes, just like the way we do it with other systems. So, but whether we use this in Galley and all the other things in Istio, that's a separate discussion thing. But yes, we still need to add support for this the normal way.
Yeah, but we're duplicating effort here, right? Because
No,
instead of cleaning the pilot dependencies on Kubernetes, we're just like changing that code, and then we'll have to change the equivalent in Galley. So,
no, but that code is that way. Yes, that is there, but I think that, I mean, it's not that much of an effort in terms of reading from this API versus like, just adding yet another small API thing. But the actual streaming stuff is where, like, if it was a big effort, then yes, but this is.
And the scalability impact is kind of the same, because even if Galley, if we did it in Galley doesn't have incremental support at this level, and or slicing or other things. So it's kind of let's first start with the simplest solution, and then we can evaluate when the rest of it is fixed.
Right. We'll take this discussion offline because we already allocated the 20 minutes to this topic, and since let me check first if other people then have more to say on this.
My only comment was it sounds like we're extending the dependency on Kubernetes in pilot, which should be an anti-pattern.
Right. So
that's a very good point, but just like service centers and other things, it's not necessarily the spec for Slice is not necessarily a Kubernetes exclusive. I mean, it can be used in any environment. It's a protobuf. So that's what we're discussing with MCP. I mean, it is sent over MCP. It can be translated from any source.
So, Costin, I don't think anybody agrees with the idea of removing service entry and using the slice. So I think there is like a misunderstanding here. In fact, we want to use the mergeable service entry.
But we can merge endpoint slices, and we can get the exact same functionality with endpoint slice as service entry.
Yeah.
Right. So this is basically the endpoints, which is right now implemented in two places. It's in Kubernetes, plugin running directly in pilot, and it's also in Galley. Right. And what Shannon is saying is that we keep updating that code in pilot instead of getting rid of it and going with the Galley and MCP. And the MCP can send the service entry with the mergeable slices of endpoints, which are the Kubernetes slices.
That's one option. But the other option is to go with endpoint, to adopt what Kubernetes is using and avoid duplication by using Kubernetes concepts.
I don't think our goal is, as Istio, is to add a duplicate API of a Kubernetes one, right?
But it's not.
We add APIs like virtual service because you can't express the same thing in Kubernetes. But now they have an API that's almost identical to Service Entry. It was literally inspired by Service Entry. So I don't think it makes sense to have a API that's essentially the same thing as the Endpoint Slice and just make your users learn yet another API that's subtly different.
And doesn't work with Prometheus and other Kubernetes native concepts. And outside Kubernetes still work because you can still use exactly the same protobuf in any environment that doesn't use Kubernetes. So we are not losing that what Shannon was concerned about.
So if the API is called Endpoint Slice, I don't see how this can mean the same thing as a service.
Remember, the service has two parts, right? It has the collection of endpoints part, right, associated with a name, and then it has the how do I talk to it part, right? The reason why they're doing endpoint slice in Kubernetes is because of change velocity, right, within large groups of endpoints as a scaling limitation. We're actually subject to the same scaling limitation, right? Particularly when endpoints have labels, right? Duplicate labels on every endpoint fully denormalized is very expensive for us.
Yeah.
And it's only going to become more so if we try to model, the reason why they're doing endpoint slice is to support a Kubernetes cluster that has thousands of nodes and hundreds of thousands of pods. We have the same physical limit. So it exists for a good reason, and we share the reason. So, and decoupling or allowing for functional decoupling of the how do I talk to it part of service from the what endpoints does it have part is probably a good compositional change. Now we can model it differently to Kubernetes. We have an abstraction layer where we do that. There would be a question about what's the point. So we have to consider that very carefully, but I don't want to just say we're only doing things because Kubernetes did an API change. They did it for a good reason. And it's not just because of etcd.
And it improved on what we have because, again, we denormalize the labels and it's more efficient than what we have in Service Entry. So it's strictly a better API than what we currently provide.
Right. And if you look at almost any service discovery system that scales, they have the same thing.
Yeah.
Consul has the same thing. Google Cloud has the same thing. When I looked in other clouds, they had the same pattern for the same scaling reason.
To clarify, I don't disagree with, excuse me, Andrea. I don't disagree with using core resources from Kubernetes if they serve our purposes. That seems fine. I just want to make sure we're not avoiding the desirability of the way Pilot gets configured is via MCP and not in another way.
Yes, no, but that.
So if we're sending like these endpoint slices over MCP, that's great.
Yeah,
I just
and I think
want to make sure that we're not like adding support for Pilot to get additional configuration directly from Kubernetes.
I think Costin is working on some things that actually push that forward faster.
Yep.
So is there a proto definition for the Kubernetes? How will we integrate that with MCP?
We would have to create one as a proto. That's
MCP already has a number of Kubernetes cores.
That looks exactly like the Service Entry then?
No, because it doesn't have the how do I talk to it part.
Yeah.
Remember, Service Entry serves.
In fact, I think it's a very nice concept to have in an API.
No, we have to have that part, right? So Kubernetes has both endpoint slice and it still has service.
Yeah.
So why
those are not mutually exclusive.
Service Entry for that purpose? So why it's already a mergeable thing, right?
So I understand technically it's mergeable, right? But there's expense in that merging today because we flatten labels down onto endpoints.
So each IP has a set of labels. In the new API, there is a set of labels and then a list of IPs. It's much more compact.
Right,
okay, so I understand. Now you use, at least we agree, we've discussed many times in the past about changing the Service Entry because it doesn't match well this incremental of endpoints needs, right? So basically what the proposal is actually to revamp the Service Entry to match a slice model.
Logically, that's what's happening, right? We want to support that there's the usability thing of like, don't make me update two things if I'm doing something really simple, right? Which is why we allow for inline endpoints in Service Entry, right? But we need to support a model where that can be decoupled for scaling reasons.
Right. So I think put this way, it's very different than we're getting rid of the Service Entry and replacing it with EndpointSlice. That's not,
We're getting rid of endpoints part of the service entry, not completely by service entry.
Well, we're not getting rid of it.
Yeah, not getting rid of it.
Right? But we are at scale suggesting that people do a more disaggregated thing.
So if somebody wants to model an external service, they might want to think of that in terms of a service with maybe a single endpoint, and not necessarily in terms of an endpoint slice.
Right. Right. I mean, this is like Envoy has the same model as well, right? They have clusters with inline endpoints, right? Or direct resolution of its own endpoints, or it delegates to an endpoints service, which basically provides what it needs. This is the same logical compositional model. You can either have the inline thing or the disaggregated thing. But for systems that need to scale up, we would have a recommendation that they don't do the inline thing. Right? If you have a high rate of churn of endpoints, right, updating service entries is probably a really bad idea.
There is the aspect that if someone is using Endpoint Slice, Prometheus, and all the services that are native Kubernetes will actually immediately see them. If they put it in line in service entry, only Istio component will see it. So it's a bit more interoperable that way. But that's probably my.
Well, Kubernetes has the same, right? They have to kind of deal with the same transformation internally as well. So
the next one. We had 20 minutes, right? And
sorry.
Yeah.
Okay, sorry. So we'll have to continue the discussion offline, maybe with some comments in the design document. Now let's move on to the next topic. So Jan, please feel free to share your document and present your ideas.
So we are going to solve the problem that node balancing between the services from internal and external services. They come from different service discovery mechanisms. So for internal, we use EDS, and for external, we use DNS resolution. And because for EDS, so if we use EDS only, then we can only send the IP address directly without putting the host name in the EDS response. So we need to extend service entry to support that. So what we are going to do is that we extend the service entry to have some node balancing hosts, which contains both internal host name and external host name, and provide some priorities to denote the failover sequences. And for example, in this example, so the traffic will go to internal fallbar.com first, and then if this hosts all fail, then the traffic will go to fallbar.com. And even we aggregate this one, so user can still apply the destination rule to the host to the host in LB host. Like user can specify the TLS context to the internal fallbar.com and to fallbar.com with different HTTP options or TLS context. And that's all. So some alternatives like using CDS instead of EDS. That's because CDS. So when you send CDS response, and then the clusters will be recreated, and then collections will lots of CPU cost. And doing DNS resolution in pilot, for example, when the pilot is very far from the Envoy, the DNS resolution is not reasonable because the response, the Envoy, so Envoy receives the IP address, and the IP address may not be reachable by the Envoy. And the last one, make EDS to the DNS resolution. So that's the implementation may be similar to aggregate cluster, but the cons is that when EDS receives the response, the EDS response will not be applied immediately because it needs to do some DNS resolution, and that's.
So probably it's good to separate the discussion on API, if we need to make any API changes to the aggregate, and the actual implementation in Envoy. So that's probably one useful.
The actual use case that drives this thing.
So the use case is that, sorry.
We should start from the use case and then go down into the, what might be needed.
Okay, so the use case is that, so we have a customer that have, Walmart has internal services and external services, and they want to, when the internal services are down, the traffic goes to external, failover to external services. That's a use case.
And in general, the problem that we are trying to solve is that we have services that are implemented in local clusters and can be resolved with EDS and load balanced and so forth. But the exact same service can be implemented by one or more DNS entries that do not have, where we do not have access to the IP addresses, and they need to go through DNS resolution. And besides fallback, we also have the concept of locality load balancing. We also have the concept of where we may want to apply pretty much all the rules that we apply for everything else. Multi-network, we can.
Yeah.
So here the basic problem is that the EDS response doesn't allow a mix of IP addresses and hosts.
And DNS
Yeah,
addresses.
that one is like, that feature is requested a couple of times in Envoy community, and it's just someone is not implemented yet, doesn't have the bandwidth to do that. We are okay with you to add that. That works for sure.
Oh, okay, so we definitely have more than one entity asking for the feature, right?
For that
the
one, yes.
question is how we implement. What is the
And
best approach?
The other thing to note is that today you can just ship a strict DNS cluster with IPs and the DNS name, and the IP addresses will just be a no op for DNS resolution, and the DNS names will just get resolved as usual. And that is a decent solution compared to which requires no API changes. All it requires is a small fix in pilot such that I should be able to define a service entry with the same host as the Kubernetes service name, and I can add a bunch of other endpoints, then we should be able to merge them. That merging logic doesn't exist in pilot yet, but we have to do it anyway, and we can add that merging logic. And if we were to add that merging logic, then it becomes a very simple thing of shipping a simple strict DNS cluster via CDS, which has the pod IPs and the 3 or 4 VMs that are being used as a fallback.
But that will not scale and will not work very well, because if we put it in CDS, in the CDS response in line, that we need to send full CDS responses. And also it doesn't scale, because what we discussed earlier was that this kind of cases is large scale, not small scale.
No, that's the thing. So that is where I actually talked to UK. I talked to UK and I talked to all of the other Walmart guys. This is not a large scale scenario, nor is this one where they have thousands of endpoints of that sort. This is all for the stuff that's happening in the Walmart, like the stores and so on, where they have few pods that is running the services on Kubernetes, plus 1 or 2 VMs that is actually supporting the same thing on VMs. And they simply want to be able to failover from the pods into the VMs if all the pods are unavailable. They do not have a scenario where this is running across 10,000 plus pods and they have like 5,000 plus VM endpoints and so on and so on.
But the general problem is scale, because everything we do in Istio, we need to do at scale.
Not always the case, because if you do it by scale, then you create a more complex solution which is not accessible to a common case. And it's always, then it goes in a completely different path. And until we hit that scale thing, we shouldn't like overcomplicate a solution that gets into more murky territories, which if we don't require an API change, because the common case, this is a change where people just don't even need that scale, then why bother with it?
So I think there's.
Are you saying there is like we can achieve this a bit faster by making simpler changes?
With just a small fix and pilot to allow actually merging service entries, they should be able to satisfy this use case today with 0 API changes, 0 changes in Envoy. And if someone puts DNS entries in EDS, we can actually we can start shipping that same cluster as an EDS cluster rather than a strict DNS cluster, and that becomes That's
So if we do this, this is strictly worse than resolving the DNS and the EDS response, right? Because now we have to send the full cluster, and anytime a single endpoint changes, we have to drop all the connections, recreate the cluster.
And so all clusters, not only this cluster. The CDS sends all the cluster in one batch.
Yeah. Why would we want to do this approach over the EDS?
Yeah, endpoints changing to the extent that when every time an endpoint changes, if it's a pod that's coming up and going down, sure, yes, we can just send that cluster alone. We can fix that in CDS to actually just send that CDS alone, right? There's nothing that prevents us from actually doing
that's
that.
not ready yet.
It still drops all the connections. This would be
Is
much
there
harder to implement private.
loss when we change the cluster?
What's that?
Today, what happens when you add and remove an endpoint in a cluster? Does it not drop connection?
No, there is no connection dropped. We send an EDS response with the additional endpoint, and Envoy just adds the endpoint to the list, and if necessary, connects to it.
There is no traffic loss if you send.
There is no change in Envoy, just adds the endpoint to the list, and if necessary, will be connected later.
How do you remove an endpoint?
If it's removed from the endpoint, then Envoy will disconnect from that endpoint.
How do you send the EDS response which says remove this endpoint?
You send the list of
We send the full list of endpoints every time.
for each cluster. But only for the clusters that change. So if one cluster is changing, we send only the endpoints for that particular cluster. And the discussion we had before about slicing it is still applies because we want to slice the EDS response as well into.
Right, but then we can do the exact same thing even in Envoy today, right? Like even by changing small changes in Envoy to make sure that when the CDS clusters endpoints are almost the same, with only a new endpoint being added or removed, we can just fix the implementation Envoy to basically not drop connections and just like.
So why not just make it
so that
Envoy do the EDS then?
Yeah,
right?
so that means dropping EDS basically. So avoid deprecating EDS because there's no point in using EDS if we inline everything, no? I mean, why do they bother with EDS otherwise?
Because you just wanted to do this whole shard business and so on and so forth. I mean, it's like, yes, that's also the equally case. Yeah, sure, if we make the CDS strictliness thing to have this incremental property, then we don't necessarily need EDS. But the point is that none of them would require another cognitive effort for people to understand what this new type of resolution is, nor have to figure out what if I declare subsets here and there, and how do I actually reconcile them, and adding yet another type of this whole thing, and it spirals on its own set of complexities. Worst case, if you really want it this way, you can always go use this Envoy filter API to create the special clusters for our customer for those services where they want this hybrid kind of load balancing, which still also eliminates the need to complicate the API with this kind of a one-off scenario.
So I have a question. If we go with Sriram's proposal, does this one preclude us from later implementing Jan's proposal?
Why would we go with that proposal? That's the question. It's the best proposal.
The problem, we have to agree that Jan's proposal is fairly involved, right? Like it requires.
I don't think we've concluded what is Jan's proposal. We have a bunch of different ideas, but there's no one solid proposal.
So I do have one question. The assumption is that the client has done DNS resolution for the host it's trying to talk to.
Yes.
Why does original destination not work as the fallback?
It should. Oh, that's actually even better. Then we can actually add. So for these cases, we can just simply change the entire thing into an original destination thing.
But how you express it? Because
there's an API. I understand there's an API problem.
I know it won't work because here's the thing, though. What UK wants is that he wants to fail over to the VM only if all the pods in the cluster have failed, and not.
Right, so
but there is no original destination. The original destination is a VIP. So when you connect to that service, you connect to the VIP, and the VIP resolves to EDS endpoints that are local.
No, I know, but that's only because we captured the VIP. If you talked to the VIP, right, you would have gone to the endpoint.
To Kubernetes. To Kubernetes load balancing and Envoy is completely out of the way. So we don't have MTLS.
Right, but if it's an external service, right, something that they had programmed in both, they've basically done a merge. Right, what would DNS have resolved to?
DNS will resolve to the cluster VIP, no?
Right, so they want to provide a DNS alias.
The DNS alias is for the external IPs, not for the internal IPs.
Right, so the app isn't aware of the external alias.
Yes, the app is not talking directly.
He also said he's actually thinking of introducing an aggregate alias for these kind of services that basically says that like I don't want to even rely on like tell people to use the K8 as internal service. I'll just use foo.bar.com, which will either resolve to VM FQDNs or the K8 as internal service. But
I strongly agree that we should not add anything to the service entry. I don't think we need to. This is not something we need for the proposal of aggregate cluster. We could still merge them with the user not actually knowing. So right now, today, if you did 2 service entries, one with DNS and one that's not DNS, Pilot actually will send the host name in the EDS response. Like it completely breaks, Envoy rejects it.
I know, but we can change that to send host names as a strict DNS cluster.
Or we could do it so it does the aggregate cluster, right?
We can add the DNS supporting EDS cluster.
Properties.
Lisa, can you please speak up because we missed you?
Yeah, well, I mean, like adding DNS supporting EDS it's totally fine. I mean, it doesn't have to be like strict DNS and inline the endpoint in the CDS.
I think the primary question is what is the best solution long term? I mean, should we have EDS extended to support this DNS, which is proposal 1? Should we do what Sriram is proposing, which is to extend CDS to get rid of EDS completely and have EDS in line?
No.
It was just to add the send us strict DNS clusters if the performance becomes an issue. Where the thinking here is a large scale extreme churn and that people will just really hate this thing. But for most people who are using standard service entries with DNS, they're not complaining about connections being terminated or so on and so forth. They're just perfectly fine, right? They're using external services, Google APIs and so on by just declaring them as DNS.
That never changes.
But we are designing it for future and for large scale. I mean, it's the fact that right now people are using it small numbers doesn't mean we should assume that it.
So I presume in the long run we would want to be able to label endpoints no matter how they were resolved, right? Because that works with locality-based load balancing and other features.
Right. And we are also doing the labeling for different like TLS context, TLS settings in the endpoint level. So
that feature is part of aggregate cluster.
It will be part if we go with aggregate cluster, yes.
No, it's not part of aggregate cluster. We're putting like TLS labels into endpoints. And
it's a TLS context selection over different labels.
That's even more. I mean, if we go with aggregate cluster, we could have some endpoint. I mean, right now the solution for
I don't like the inconsistency of like by putting the like different like TLS settings into aggregate cluster and have putting per label selection.
But it's more than that. I mean, the cluster has a lot of options that allow you to set that particular set of endpoints has a number of ways to connect to that. I mean,
right, but if the general trend in Envoy is that they're going to bind features to endpoints using label selection on the endpoints, right? So if I have multiple TLS contexts with a label selection, right, then, right.
But then what is the purpose of clusters? I mean, if endpoints is EDS is taking everything.
It's another way of expressing the aggregate cluster concept.
But it's hierarchy.
They just don't have names.
Yeah, but I think except for like TLS, we need to express HTTP option and other options apply on cluster.
Right. So Gazan, I guess the question for you is: are other things beyond just TLS? Like, is this pattern going to be for everything, every capability of the cluster, including protocol selection and other features, and not just for TLS?
And what's the implication on scalability? Because again, we just discussed that it's better to have the endpoints kind of sliced and diced and have different labels kind of a top level versus putting in each endpoint as labels pretty much all properties.
And then having Envoy do the join.
And with a huge set of data.
And there is also the priority. So the issue is called failover, right? So Jan's proposal with the aggregate and the cluster allows you to set a certain priority here. And I'm not sure if what Sriram proposed allows the same, unless it's something.
We can do it.
That's in the locality load balance.
Yeah, we have it in pilot today, locality-based failover. So the idea is that you declare a service entry where you specify the locality for your internal pods and a separate locality for your VM-based DNS endpoint. And then you just define the mesh level thing that says like failover from the pods to the VMs when they all fail, and that's it. And that basically it works today. People are doing the same locality based like failovers and whatever the load balancing today. And so that exact same principle applies on this VMLAN as well.
Okay, thanks for clarifying. So that would not be like an area of concern then.
Yeah. The problem with aggregate cluster is it creates a top-level cluster, which in turn has two sub-clusters, like a smaller VM cluster and endpoint cluster. And there'll be a total of 3 clusters that needs to be declared. And the moment you start talking about 3 clusters, we have a bunch of properties on clusters, from protocols, TLS context to subsets to whatnot. And we now have to start resolving all the the interplay between all of these properties across 3 different clusters, as to what happens when you define some subset in one but not in the other. And or for example, if I just select a bunch of VM endpoints and a bunch of pods together as V1 and something else as V2, how are we going to create aggregate clusters? Are we going to create 6 clusters in total, or are we just going to do simple 2 clusters like what we do?
I think our goal is to do failover, so I think the 2 clusters should be separate, right? So
it's not only to failover, so to be clear, failover is one use case, but we want this to work for everything, including load balancing. I mean, it's not, we don't want to stop just failover.
Yeah. And failover is already supported with existing.
I understand you have longer term goals here, especially to align this with the endpoint slice, right? I get this. On the other hand, we need to find some practical solutions for a so urgent problem, right?
Do we have urgent problem right now?
Yeah.
I mean, so UK and Robert Vance, I mean, the Walmart folks, they wanted this functionality for the extending the mesh, but the solution is rather much more simpler than going with the aggregate cluster, unless it is a real, what do you call, showstopper scale issue, which does not seem to be the case after talking to him.
Yeah, even in short term, we go with this solution. Again, we still need to have a design that works longer term and satisfies scalability and integration with other features.
Right, but in the longer term, can't we do what Lizanne was suggesting, that support and DNS and EDS, at which point that we can offload a whole bunch of CDS stuff out into EDS, and we'd get best of both worlds, right?
I'm okay with that. I mean, I don't think it's...
I'd be okay with...
Keep in mind,
okay with DNS and EDS.
Selective TLS context as well. VM endpoints may not have TLS, so we still need to do the same selective TLS context stuff that works.
So I think the implementation of EDS support DNS is actually same as aggregate cluster.
Yeah, but it
without API changes.
Yeah.
Without API changes on our
The
side.
best part is we actually don't need to change pilot at all, because it already assumes that it's works.
So basically just fix pilot, because right now it's crashing if you combine them, and yeah, that's a good point.
I don't actually think we need a single change to pilot for this.
Okay.
Yeah, the thing is we already do a lot of endpoints grouping and a subset load balancer and the TLS thing is going on to that. So overriding some cluster level setting by selecting some subset of endpoints, you can do that in Envoy as well.
So the conclusion will be that we'll add some DNS entries in the EDS response, and they will be by default strict DNS or what? Because there are different variants of DNS.
Yeah.
DNS entry, I mean, that I guess depends on the resolution type. So I think it just be strict DNS. We just resolve it, get a bunch of IPs and add them into the pool.
Yeah, I think the EDS response actually already has a resolver name in it. I don't know if this is
we have
to resolve it.
That one doesn't work today. But I think that people request to have EDS response have the DNS with resolver name, or do whatever they strict DNS resolving.
Any guesstimate on how long it will take? I mean, can we get it in 1.4?
I don't know. I ever talked about this one with Harvey, but he doesn't support that to use EDS to support DNS.
So what does he support?
So he says, because he thinks that one is concept equals to aggregate cluster, and
so I agree with him.
Harvey told us to talk about this in this meeting. He said he's not convinced about aggregate clusters either. So that's what he mentioned.
So, Lizanne, you're the one who made the argument that we should align with the existing Envoy pattern of relying on labeling, right? Because that's going to be used to select other features onto these endpoints. So if we are beholden to that requirement, then the only way to achieve that effect is DNS in EDS, right?
Not necessarily, but you can still rely on labeling and have separate clusters. I mean, the interaction between clusters is not something that is...
Right, but none of the load balancing things work with that.
Unless aggregation happens. I mean, you have
right, so locality LB won't work with that. None of the existing other Envoy features.
Well, we already have the locality.
Unless you are aggregated. You take two clusters, you put them together, and you treat it as a single cluster, basically. But you still send two different, and you may still have some different properties at cluster level.
You still have the locality and zone in the
locality. Yeah, that's in endpoints. You just merge. You take the cluster 1, cluster 2, you merge them.
Yeah.
So is that equivalent? Either you send EDS, a larger EDS with more labels, or you send slices, which cluster representing a slice, and then you put them together in.
Right, but the only thing sliced are endpoints with labels.
Yeah, but you can slice it further if you choose to. That's kind of the nice thing. That's why.
Sure, but like at some fundamental level, you have to get down to an endpoint having labels because that's how you bind capabilities within the cluster specification.
But over the wire, you don't have to have this kind of.
Right, that's an API change as far as Envoy is concerned.
Slides. Yeah,
they don't merge clusters.
I agree. Well, no, that's implementation change. They will need to merge clusters, or they will.
Right, and therefore, by definition, the merge cluster they'd have to be able to represent the same concept in a single resource type.
Yeah, possibly.
But otherwise, they'd have wild API problems.
I know. But there are benefits as well.
Lizanne, you need to go argue with Harvey. Yeah. Is what I'm saying.
Either of them will work for us.
Because you're advocating basically that only one of those solutions is aligned with the existing Envoy roadmap. Yeah. Or features, other features.
No, well, it's all the balance between like how much things you put in the CDS and EDS, right? It's like aggregating stuff. You can basically having the cluster, bunch of clusters, and having the aggregate.
Right, but if you said that like the TLS context selection is really only going to be implemented based on label match against endpoints.
Yes.
Then we're just going to end up with a bunch of duplication around TLS context selection for two clusters within the aggregate.
Yeah.
Which seems totally redundant.
No, the selection part is how do you specify based on the label is specified in CDS?
No, I understand what the criteria are, but the thing it matches against. And in an aggregate cluster, right, we have effectively two cluster specifications. Right?
Three, not two, three.
Sorry, okay, three. Each of which will have to have a TLS context selector, right? That is duplicate.
The top level cluster is actually just a concept cluster. It doesn't do any like a real connection to node balancing, delegate the node balancing to the inner cluster.
Right. And don't get me wrong, by the way, I actually think like if I were to choose, I would think aggregate cluster with feature inheritance is actually probably a better option as long as you could select, as long as the aggregate cluster could select the child clusters with more flexibility, because it probably scales better.
Exactly, and has better future in terms of scalability, and has the same arguments that Kubernetes went to for slices, where less traffic on the wire, less terabytes of data.
You're making an argument that TLS, like we're not going to do like TLS context selection inheritance from the aggregate cluster, so you'd have to normalize it down into every leaf cluster, right? And so you have all this redundancy.
What's possible too, Costin, is if we go with the DNS in EDS, that's a good short-term fix for this. And then long-term, we'll have incremental EDS, and that will solve that problem. So
I agree. We can do both, basically.
Yeah. So that's what I'm saying. Like short-term do EDS in DNS, and then incremental.
I'm happy with that.
Yeah, I'm happy with that as well.
Everybody happy? Shriram also?
Yep.
Okay.
So consensus, wonderful.
I'm okay. So if you can like talk with Harvey, say okay, we do EDS with scans.
So chat with Lizanne.
Okay.
Yeah, I'm going to talk with Harvey.
Yeah. I'll talk to Harvey as well.
Okay.
Okay. So here's the problem. We went way over time with both discussions. The first one was supposed to be quick, and it was like 25 minutes. And now we are going on to the third item. And Mitch, I think, is there in the room. And Mitch, how would you like to proceed? You want to,
next week? Or
so my proposal is fairly simple. Okay. And so I think what I propose is that you look at the document offline if you're interested. At a very high level, the 30-second pitch is I'm proposing we begin hashing config versions in pilot, using those hashes as nonces to XDS, and leverage that data to help our customers understand when a config change has propagated out to the proxies. The details are all in the document. and I think relatively boring, but I do address comments as they come in. If there are enough comments, I'd be happy to come back, not physically, but virtually come back in a week and talk about them again. If not, I'm already kind of into the implementation phase, so I can just move forward if there aren't any.
Yes, let's do it, because this has been in our minds for a long time, where we wanted to use some semantic ways of like something in the version that actually allows us to track whether a config has propagated all the way to data plane or not. The problem is that the nonces that we send, are they specific to, in an ADS thing, is it one single nonce for the entire chunk? No, right? It's one nonce for EDS, one for CDS, and one for LDS, right?
Yeah, it's a different nonce per resource.
But the base of the nonce will be still the hashed.
Yeah, we would use the hash as the prefix of the nonce, and then we can continue with a UUID for the suffix.
The problem here is this, right? So it's like, even if it's, let's say, LDS, it's a composition of multiple resources. So if it's a question of like, to what granularity do you want to track the update propagation? If you want to track the propagation of this virtual service all the way down into the route, that is a nonce in RDS and sometimes possibly in LDS as well.
Yeah. So Sriram, the design accounts for that by hashing the entirety of the config. But like I said, if you have concerns about that, I'm happy to come back and talk about it in detail in a week.
Instead of doing the hashing the entirety of the well, I guess hash is a decent way to do it, I guess. Sure. Because the point is that you can, instead of doing the hashing the entire config, which is not going to be of that much use, basically because due to eventual consistency, some pilots may have all and some pilots may not have all, and each one is going to have a different like hash. And from an end user point of view, when you look at the hash, they will not see. Instead, well, but there's no solution for this, because the point is to create the concept of epochs, which is like, at this epoch, this is all the configuration that this pilot has, and we could have a linear ordering across all the pilots in terms of not necessarily all the epochs potentially, such that the end user should be able to see, like, okay, this Envoy has only configurations from epoch 1.
Okay, sorry. Is everybody still there?
Survived?
Yeah, we're here.
Okay, so I stopped. I didn't know how to stop Jan, who started showing us all kinds of things. So I hope now it's everything good. All right, good, perfect. Go ahead.
I guess the concept that if we have this concept of epochs, where we can actually tell the end user that this is these envoys are an epoch 1, where epoch 1 only has these configurations, then that would be great. But then that effectively this idea of like, you need to have a central repository of what each epoch is, and some form of linearization of these epochs. So epoch 1 follows 2, follows 3.
Yeah, I like this, but I don't think it's possible since eventual consistency.
Right, and so in that point, at that point in time, then when you do this hash thing, then what is it that you're gonna return as a response to end user when they ask, like, has this config change made it?
So basically, you'll be able to use the hash or the tree to answer the question of which version each proxy is on for a particular config. The user interface is, I want to be able to run similar to like a kubectl wait, Istio cuttle wait for this virtual service.
So basically, you'll go to each pilot, asks the pilot, hey, you have a configuration for this hash.
Yep.
And if pilot still has it, presumably then pilot will give you back the response.
That's right.
You could get multiple hashes, right? Because if I wait for a virtual service where 3 pilots have the same virtual service, but other configs are different, they would have 3 different hashes.
Yeah, the user actually doesn't specify the hash. They only specify the object, the virtual service or other object that they're interested in. Right. Pilot then retrieves the hashes from the nonce mapping on the connection, looks it up in its own table, and returns the version that each proxy has.
But the hash will be, it's ephemeral because we replace push context is very fast. So if you get two config pushes, you have the previous hash and then it's gone. So you cannot ask for it anymore.
No, the tree actually can store historical hashes, and then we can control how long that history is.
So because it's a Mercury tree.
So I have a proposal. This is going into very detailed discussions. I'm sure not everybody had the chance to actually read and understand the proposal. And there is one thing which I may have missed, which is the utility. What is this good for? And I actually found it in the document, right? So
It's a debugging feature.
you explain and I missed it, or
It's mostly debugging, yes.
no, it's not the debugging. It's actually, it helps with the status with Knative identifying when Istio is ready to receive traffic. Is
There are
that
other ways for, yeah.
Yeah, Knative and similar use cases.
use case? And they have been complaining a lot in the past that they don't know when Istio is ready. And Mitch's proposal will help with that. Is that correct?
Yeah.
That is correct, yes.
It's also not just
Yeah.
Knative too. It's also normal users or tests even. There's a lot of other use cases as well.
But
Right.
it's not clear that this hash solution is the simplest solution that will work. I mean, there are other alternatives that are discussed, including my favorite, which is events, sending events when something
Yes.
was propagated.
Yeah, but for that events, we need to have a system that actually.
Everybody, and see you in 2 weeks. Present.
Okay.
Bye.
See you next week.
Days.